Okay, guys, I'm hoping you're having a great day. I'm sorry I'm not with you right now. But what I want to do is just go over a couple quick things with you guys. In this next section, we're dealing with the idea of polynomial functions. And what I want to make sure is that you guys understand anytime during the videos, you guys can always pause it or ask the teacher to pause it or stop it if you guys want to copy what I have written down. But a polynomial function is an expression that can have constants, variables, and exponents that can be combined using addition, subtraction, multiplication, and division. But you can have no division by a variable. What I mean by that is, like, you can't have something like 6 over x. That is not a polynomial function. Not good. And your exponents have to be 0, 1, 2, or 3. More specifically, they have to be whole numbers, and it can have an infinite number of terms. So when we look at polynomial functions, here's some other key terms that we want to know. That the degree is the highest power of a polynomial function. We're going to look at some of that in this little bit. That a constant term is a term that does not have a variable attached to it. The leading coefficient is the number in front of a variable with the highest power. And standard form is when the terms are written from highest power to smallest power. If the teacher wants, or you guys can stop it right now if you guys want to write down what I have written down. But I'm going to go on to the next one right here. These are the key ones that we want to focus on. Based off degree, that the highest power can be 0, 1, 2, 3, 4. These are just some examples of what they could look at. If you guys notice how, if it's a degree 2, that means that the highest power is 2 in this function right here. The highest power right here is 1. And based off the highest power, that's where we get the type. Now, if the highest power is 1, or the degree is 1, that means it's a linear function. That's what you guys spent a lot of time on last year. When the highest power is 2, that's what we call a quadratic function. That's what we're going to focus on a lot this year. The next one is degree 3, which is considered to be a cubic function. And when it's degree 4, that means we have a quartic function. So knowing this, knowing the degrees and the types, and we know that a polynomial function can have anything with addition, subtraction, multiplication, or division. We can't have a division by a variable. The variables have to be whole numbers, and it can have as many terms as we want. What I want to be able to do is I want to be able to look at examples like this and decide whether or not the function is a polynomial. If it is, I want to write it in standard form and state the degree and leading coefficient. So when I look at this, are all of my powers whole numbers? Well, that's a 2. That's a whole number. 3, that's a whole number. And that's a 1, so that's a whole number. I don't have any division of any exponents, and I can have as many terms as I want. So this is a polynomial function. So what I want to do is write it in standard form. Highest power is first. So I'm going to put negative 2x cubed first. So that's the highest power. Then I have plus 3x squared plus 4x. That is what standard form would be. Highest power all the way down to the bottom. So what is my degree? Well, what is the highest power? It is a 3. What's my leading coefficient? The term that's in front of my highest power. And that would be negative 2. Now, based off my degree, I can say that is a cubic function. Okay. Looking at this example. All right, is negative 3 a whole number? No. Is 1 of the highest power? This one is a 1. Well, that is 1. And that's power is 0. But because one of the values is not a whole number, this is not a polynomial function. Because 3x to the negative 3, this is not a whole number. Okay? Let's look at these. Well, let's look at number 3. Okay, let's see here. What is true about this power right here? Well, it's a root, and I remember we can rewrite this as x to the 1/2 power. Is 1/2 a whole number? It's not a whole number. For all those guys who yelled that out, congratulations on that one. So this is not a polynomial function. Okay, looking at this one, that's a 5, that's a polynomial. That's a 0, so that's a polynomial. 2, so that is a polynomial function. So then what I'm going to have is I'm going to have 2x to the 5th plus 7x squared minus 3 is my standard form. My degree, or the highest power, is 5, and my leading coefficient is 2. What I'm going to ask you guys to do, I want you guys to look at the next two. I want you guys to try to guess what those are. When you guys feel like you're ready, let the teacher know, and we can go over it. Okay. Well, hopefully this is what you guys got for 5 and 6. You found that 5 is a polynomial function because all the powers are whole numbers, 2, 1, and 0. That means the degree is 2, and my leading coefficient is -1/6. Number 6 is 1 as well. All the powers are whole numbers. Does not matter that square root of 5 is irrational, but all the other powers are. So that means that the degree is 4, and the leading coefficient is square root of 5. Hopefully this is helpful. You guys are going to use this more on an assignment that I have for you guys today. But now we're going to go on to the next step with adding and subtracting polynomials.